Hello, I am Pankaj Sharma from Brainleague Learning. In this lesson, we will build a clear, intuitive picture of drift velocity in conductors, and then we will derive and use the key formula, V sub d equals I divided by n times q times a. Let us start with a simple circuit fragment. On the left is a battery, and on the right is a long piece of metal wire. We draw the wire horizontally. We add the battery plates with plus and minus. Inside the metal, there are many free electrons. We will draw a few as blue dots. When the battery is connected, an electric field pushes charges along the wire. We show field arrows to the right. Electrons jiggle randomly due to temperature, but they acquire a tiny average drift opposite the electric field. That drift is very slow compared to the random thermal motion. By convention, current points in the direction of positive charge flow, which is to the right in our wire, while electrons drift to the left. Let us label both directions now. Now, what do we mean by drift velocity? Drift velocity, V sub d, is the average velocity of charge carriers along the wire due to the electric field. Even though each electron is bouncing around quickly in random directions, the average motion has a tiny net speed. We write V sub d equals the average displacement per second along the wire. In circuits, we use current density, J, which is I divided by the current per cross-sectional area. At the microscopic level, current density equals N times Q times V sub d, where N is the number of free carriers per cubic meter, and Q is the charge on each carrier. Therefore, I divided by A equals N times Q times V sub d. And so V sub d equals I divided by N times Q times A. Let us do a realistic calculation to feel the scale of drift velocity. We will assume a steady current of 3 amperes in a copper wire with a cross-sectional area of 1 square millimeter. We take N as 8.5 times 10 to the 28 per cubic meter for copper, Q as 1.6 times 10 to the minus 19 coulombs, A as 1 times 10 to the minus 6 square meters, and I equals 3 amperes. We start from V sub d equals I divided by N times Q times A. We substitute the values. 3 over open parenthesis 8.5 times 10 to the 28 close parenthesis times open parenthesis 1.6 times 10 to the minus 19 close parenthesis times open parenthesis 1 times 10 to the minus 6 close parenthesis. Now we multiply the denominator. 8.5 times 1.6 is 13.6, and the powers give 10 to the 3. So N times Q times A is about 1.36 times 10 to the 4. Therefore, V sub d is approximately 3 divided by 1.36 times 10 to the 4, which is about 2.2 times 10 to the minus 4 meters per second. That is 0.22 millimeters per second. Very slow. And remember, in a metal, the drift of electrons is opposite the direction of conventional current. Let us summarize the key ideas. 1. Drift velocity is the tiny average motion of charges along the wire. 2. The formula is V sub d equals I divided by N times Q times A. 3. Conventional current points with the electric field, while electrons drift opposite in metals. For drift velocity is typically very small, millimeters per second or less, even when current is several amperes. Thank you for learning with me. This is Pankaj Sharma from Brainleague Learning. Keep exploring physics with intuition and clear pictures.